Hello and welcome everyone to our monthly Windows app community stand-up. I'm Christina Warren. I'm a senior cloud advocate here at Microsoft, and I'm super excited to introduce Mr. Michael Von Hippel, who is a PM on the Windows team. Michael, how are you?
Hey, Christina, I'm doing well. Thanks so much for having me. I'm really excited to be here.
And we're super excited to have you here. So, what are we going to be talking about today?
Today, we're going to talk about the latest pen and inking capabilities. If you caught the Surface event earlier this morning, you may have noticed the announcement of the Surface Slim Pen 2. That pen is awesome, and it really provides the feedback people expect from a traditional pen on paper.
Yeah, I saw the announcement. I was super excited. I'm kind of a nerd about penning experiences, so this totally checked all my boxes. No pun intended. And these devices are pretty awesome. The accessories, as you mentioned, are great too. And it was really great to see. I think I'm quoting Panos here to say like the hardware and the software complementing each other, right? So when I was watching all of this, I kept thinking, okay, so how should developers be thinking about the pen announcements, and how should they be thinking about what these new devices and accessories can do?
Well, for me, the most exciting thing for developers from this morning was the Surface Slim Pen 2, but I could be biased. In all seriousness, the new tactile pen capabilities are available for developers to explore now, and we created a sample app that developers can start playing with to help them integrate the technology into their apps with limited lines of code.
That's awesome. And so we're going to go into the first. I think you have something to show us with that, right?
Yeah, absolutely. We'll be showing off the new capabilities introduced on Windows 11, which make using a pen feel even more natural on supported devices with tactile feedback. Now, users are able to feel interacting with their screen, creating a more natural and intuitive experience. We support two types of tactile feedback experiences: inking feedback and interaction feedback. Inking feedback is feedback that plays continuously while the pen is in contact with the screen. This feedback is intended to simulate the feel of various types of writing or drawing tools, such as a marker, pencil, highlighter, and more. Interaction feedback is short and direct feedback to confirm key actions, such as hovering over or clicking a button, providing feedback for completing an action, or when you want to draw a user's attention to something. A great place where you can try out both types of feedback is in the handwriting panel. When writing, you'll feel inking feedback. And after you complete a correction gesture, you'll feel interaction feedback.
This is really, really cool. But going back to kind of developers, which is our audience here, how should they think about adding like this tactile feedback into their apps?
In this next demo, we'll explain the simplest way to take advantage of tactile feedback while inking. But first, I'd like to make a quick note on naming. When we talk about this feature with users, generally we use the friendlier term, tactile feedback, because people already understand the feeling in their fingertips, like the bumps of braille or the sensation of lead hitting the paper when writing with a pencil. The API uses a more technical term, haptics, which refers to the mechanism for playing those signals. We'll be saying haptics for the rest of this talk.
Awesome. All right, let's take a look.
The first thing you see here is the standard ink canvas control. It's completely unmodified, and the great thing is that it provides haptic feedback for free for each of the built-in brushes. Here, I'm using the default pen, and I get a smooth, sturdy feeling, much like a ballpoint pen on paper. Now, as I'm doing my inking, it's also reacting to the velocity and the pressure that I'm applying on the screen to change the signal to better simulate what it actually feels like on paper. Now, when I switch to the pencil, I get something more scratchy, and it feels like a pencil on paper to me, which is pretty different from the pen that I just felt in the previous example. Lastly, I can switch to the highlighter, and here I get something smoother, like taking a real highlighter across paper. This one's really nice as you're doing these big, broad motions as if you'd be highlighting a bunch of text. These different feelings really combine to create a more intuitive inking experience, and I can't wait for all of you out there to get to experience them for yourself. Now let's take a look at the code for this. Here you can see my XAML, and all I've done here is add the default ink toolbar, and down below, the default ink canvas. And if we take a look at the code behind, you'll see there's absolutely no new code here required for haptics. All that I'm doing here is setting the size of my canvas.
That's really, really cool. So that is the 0 line of code way to add haptics to your apps. However, I know that a lot of apps out there actually have their own custom inking experiences. So how should developers incorporate that into their apps?
Great question. So to start with, I'd like to mention that this kind of mechanism is very similar across inking and the interactive experiences that I mentioned earlier. But the general flow for sending haptic signals is first, detecting when there is pen input on the screen. Second, determining if that pen itself supports haptics, and if so, what signals it supports. Then you can send your desired haptic signal or waveform with configurations, and finally, you can stop that waveform. We'll first start by showing you how to detect a pen and see what haptic capabilities it supports.
Let's take a look.
Here we have a simple demo that looks to see when a pen is in range and then determines what haptic features it supports. Here, you can see when I bring a supported pen in range, it outputs the various features that this pen supports. And if I bring a pen in range that doesn't support haptics, it tells me that as well. So, how can you determine what a pen supports? To do this, you use the pen device object to get access to its simple haptics controller. Now, I'll be doing this in the pointer entered event for my app's main canvas, and this is going to fire as soon as the pen is in hover range of the screen. In the event handler, the first thing I'm doing is checking to see if the current pointer device type is a pen. If not, I'll exit out. If it is, I then attempt to retrieve the pen device associated with that pointer event. Now, this will only return a valid object for pens that provide advanced functionality, like either pen ID or, in this case, haptics. So again, if it's null, I'll exit out. Lastly, I then attempt to retrieve the pen device's simple haptics controller, and this is the last check that you'll do. If this is null, the pen does not support haptics, and again, I exit out. Now that we have the simple haptic controller, we can see what specific waveforms and features this pen supports. This is important because not every waveform and feature is required to be supported by every pen, which lowers the barrier of entry for pen manufacturers. However, we do enforce that two baseline waveforms are supported, ink continuous and click. These provide coverage for a large range of scenarios, which is why they're always required to be supported. The next couple of demos will show sending a desired waveform or falling back to one of these if it's not supported. But for now, we'll just query the capabilities to output what is supported on this pen. So, to check if a waveform is supported, you iterate through the simple haptics controller's supported feedback collection to see if the desired waveform is present. Here, I'm running through each of the possible waveforms and adding to my text string if it's there. In addition to waveforms, there are a handful of additional features that a pen may support. This demo will only show how to use the intensity feature, but here you can see how to query for each of these additional features. They include intensity, play count, play duration, and replay pause interval, and you can find more information about all of these in the API documentation.
Okay, so that's how you can make sure that the current pen supports haptic signals. Now, how should developers use this?
In the next demo, we'll show you how to send inking feedback. But first, I think you should remember that inking feedback is designed to simulate various writing tools while the user is inking. So if you're doing custom inking in your app, this is the pattern you'll be using to send haptic signals to the pen to make sure that they match the brush that your user has selected.
Gotcha. All right, let's take a look.
In this demo, I have a dropdown that lets me choose what feedback I want. Now, a note for you watching, I won't actually be drawing ink in this box. Rather, I'm just using it as a place for me to put the pen down and have haptics get fired as I move it around. You'll see a message below the box indicating what feedback is being played. So now, when I touch my pen down in the box below, I begin to feel the proper haptic feedback. In this case, it's the ink continuous feedback, which corresponds to the ballpoint pen you saw in the first demo, and is one of the required waveforms that all pens must support. Now, I can choose the brush feedback, which gives me a silky, soft feeling, like bristles sweeping underneath my pen. Lastly, I'll choose the marker, which feels velvety and bold, like a permanent marker. Now here, I also have a slider that lets me adjust the haptic intensity. Once this is set, I now feel a less intense version of the feedback. So now, let's see how you can manually invoke feedback like this in your app. Again, I'll be using the pointer entered event. First, I do that same check that you saw before to make sure that the pen supports haptics. Then, I have a little helper function to set the waveform based on what's currently selected in the dropdown. This attempts to set the waveform to what is currently in the dropdown by checking to see if the selected waveform is in the Simple Haptics Controller supported feedback collection, and then setting my selected waveform to it. Here, you can see the full set of possible inking waveforms. These are brush continuous, chisel marker continuous, eraser continuous, galaxy pen continuous, ink continuous, marker continuous, and pencil continuous. If the waveform was not supported, I instead set it to be ink continuous, which remember is guaranteed to be supported by every haptic enabled pen. Next, I check to see if the pen supports changing the intensity of the signal. If so, I call send haptic feedback, passing in the current waveform and the intensity value. If not, I simply call send haptic feedback without passing in the intensity value. Now, it's important to note that for inking feedback types, the feedback does not start once send haptic feedback is called. Rather, it will begin as soon as the pen tip touches the screen, and it will likewise stop once the pen is lifted. This is why this should be set on the pointer entered event rather than a pointer pressed event. Lastly, I look for the pointer exited event to call stop haptic feedback to ensure that the pen does not have a saved state, which could cause it to play haptics where I don't want it to the next time it comes in contact with the screen.
Okay, so now you've shown us how you can add haptic feedback to inking, but what about other experiences?
For those other experiences, you can use interaction haptic signals, which are short bursts of feedback that should be sent in response to user actions, such as pressing a button, manipulating a control, or interacting with other parts of your UI. We'll show you how to do this in the next demo.
You know what I'm going to say? Let's take a look.
Again, I've got a dropdown that lets me choose which waveform to send. However, this time, I have a button that plays the feedback when pressed. So now, every time I press the button, I'm getting a little click feedback. This is just a real nice little sensation coming into my hand to confirm that I've successfully pressed that button. Now I'll switch over to the error feedback. Here when I press the button, I'm getting this little double burst coming into my hand to really draw my attention to it and let me know that something may have gone wrong. And, as with inking feedback, I can also adjust the intensity to get a different feel, as here the feedback now feels lighter in my hand. The code here is very similar to the inking feedback demo. Again, I'll be using the pointer entered event handler to make sure the pen supports haptics. I'll also be using the button's click event handler to trigger the haptic feedback on demand. So first, here's the exact same code you saw before for checking the haptic capabilities of the pen and getting me a handle of the Simple Haptics Controller. Now, here in the click event handler is where I'll actually send the haptic signal. First, I check to make sure I have a valid haptics controller. Then, I again have a helper function to set the current waveform based on what's selected. Here, you can see the available interaction waveforms. These are click, error, hover, press, release, and success. Like the inking feedback demo, I make sure I can fall back to a waveform that's guaranteed to be supported. In this case, that's the click waveform. Next, I do the exact same call to send haptic feedback as in the previous demo. The only difference is that, since this is an interaction waveform, it gets played immediately versus when the pen tip hits the screen.
Very cool stuff. Now, Michael, you mentioned that the handwriting panel uses the inking and the interaction feedback together. How does that work?
Great question. The pen can actually only play one waveform at a time, regardless of whether it's inking feedback or interaction feedback. In order to make both of these types of feedback work together, what we do is we switch between them. And this next demo will show you how to transition between the two types of feedback.
Let's take a look.
Here, I have a canvas with some grid lines drawn on it and a box. I can use my pen to drag the box around, and when I do so, I'm sending the ink continuous feedback as I'm dragging it, which starts at the same time as the box changes color. This is giving me a really nice physical sensation as I move the box around. You'll also see that I get some previews that will allow me to snap the box to the grid lines. When the box enters into one of these snap zones, I get an additional buzz in the pen, coinciding with that preview visual being drawn. So here, I'm getting really nice constant feedback, but it's also paired with a noticeable bump every time I hit a new snap target. Finally, if I release the box and it snaps, I get another haptic buzz telling me that it successfully snapped into place. In the interest of time, I won't jump into the code behind this, but it's really just combining the previous two examples together, along with some code to handle moving the box and some math to figure out the snapping behavior. If you want to explore the code yourself for this, or for any of the other demos, it'll be included in a new Pen Haptics sample going up on GitHub.
I love this. This is all really, really exciting. So what we've actually just seen are a couple of examples of how you can start adding haptic experiences to your apps.
Yeah, tactile feedback is a new and exciting interactive enhancement, and we can't wait to see how you decide to use it. So please go to aka.ms/penhaptics and check it out.
That's aka.ms/penhaptics to get all the details. I'm super excited, and I can't wait to see what types of apps are built to support this stuff. Okay, we've got a lot of questions coming in from the community, so let's go ahead and get to some of them. All right, so this is one of our first ones. What does haptics feel like? This is sort of an esoteric question, but Michael, how would you describe this? How would you describe how the haptics experience, like I guess, sensation feels?
It's a great one because it's the hardest thing for you to really tell without using a device. So the user may feel a sense of friction, like a ballpoint pen, or a slightly scratchier sensation, like a pencil. We have different haptic waveforms for different writing instruments. The user may also feel a slight bump that can reinforce visual on-screen feedback that an action has occurred, or maybe to provide satisfying confirmation when a visual feedback isn't possible.
I'm really excited to be able to experience this for myself. Okay, so this is a good one. Can Win32 apps use haptics?
Yes, you can use the pointer ID in the WM pointer messages to get the pen device, which in turn lets you get access to the simple haptics controller and our haptics APIs.
Okay, all right, good stuff. So Win32 apps are supported. Now, what about apps that are using the WinApp SDK?
Yeah, the current WinApp SDK preview allows you to access the pen device, which in turn allows you to get access to the simple haptic controller, just like a Win32 app.
Okay, awesome. So both WinApp SDK and Win32, good stuff. So we've got some questions. You talked a little bit about the different inking waveforms. Can you go into a little more detail about what those are like?
Absolutely. So we have waveforms that are designed to be related to the most common inking tools, which apps can support. The most common of these is ink, for sure, which is why in our demos we explained that it's required to be supported by every pen. So this is the default pen feel. If you just have any kind of pen and you want to have one simple thing, go for that ink feeling. Then there's others like chisel marker, which you can think of like a highlighter, a bit squishier. Pencil, brush, marker, and eraser are some others that can really enhance and make sure that you feel like there's depth and there's a lot of predictability. And when you select a certain tool, it'll match the feeling.
All right, so I'm going to put you on the spot here, Michael. I know this is going to be like picking one of your children, but what's your favorite?
My favorite so far is the pencil. It's something where when you first use one of these devices, everyone's had this vision of, I use a tablet and it's just like pen on paper. And this is the closest that I've really ever seen anything to come to it. So I'm really excited to see more people getting their hands on it.
Okay, all right, I'm excited now because as we've discussed offline before, I'm into these sorts of things. So, all right, so you like the pencil waveform the best. All right, so we talked about the inking waveforms. Now, what about the interaction waveforms? What can you talk a little bit more about what those experiences are like?
Definitely. while we have interaction waveforms similar to inking ones that are various, they're things that you can't relate to a physical kind of concept as much. So when we talk about them, we see these as being really short interactions that you could see in a lot of different places. Click, for example, like ink, is required to be supported on every pen device. And so we expect app developers to use this pretty frequently. Some of the other waveforms like success, hover, press, and release make more sense in specific contexts. And so you'll want to experiment with these to see which makes sense for various controls and interactions within your application.
Yeah. So, could you maybe give an example of like how some of these things might be used? Like in my mind, I'm imagining like if I sign a document on a form, and I've completed something and I've entered it, like I would get the feedback to say I've successfully signed. Is that right, or should I be thinking about it in a different way?
Totally, that's a great way to think about it. These should really relate to the states of your app as much as possible. We like to use hover a lot as a way to sort of have those more gentle interactions where you hover over something and then you feel something. Same with the release state when you're releasing a button. But these success error states are really important for conveying whether a user has done something successfully. So I think an example like that, finishing inking and feeling success, is a great way to do it. Similarly, if you try to submit a form and that form is incomplete, you could play an error message. Or if you're hovering over a button, which would change the state of the application, you could use the hover waveform. All of these are great tools to refine your application.
No, I like this a lot. And I mean, I know we're not kind of getting into accessibility here, but I think that there are probably some really interesting opportunities in that space too for people with different capabilities. So that's really interesting to think about. All right, so this is another question that's come through. Can you design your own waveform?
This is a really interesting one. No, you can't create your own waveform. But if the pen supports it, you can adjust the intensity of the signal, as well as how many times that signal will repeat, and the delay between repeated firing to be able to tweak exactly what the user is going to feel. For
Okay.
example, in the demo, when you're moving the box around, we use a lower intensity inking signal to provide feedback that you're moving something around, but it's different from the regular inking feedback. With this customization, you can still create a variety in tactile feedback and textures and interactions for your users to be able to suit the exact use case of your application.
Okay. All right. Very cool. Now, what about being able to play, or I guess use multiple waveforms simultaneously?
No, you can't play multiple waveforms at the same time. You can only play one at the same time. But as you saw in the demo, what you can do is interrupt the inking signal with an interaction signal, be it click, success, error, any of them. And then once that interaction signal has finished playing through the parameters that you've set on it, you can then have the inking signal continue afterwards. And this will happen by default. So in the case of that demo, we allowed clicks to play intermittently as we had that kind of muted ink signal playing continuously as you move the pen.
Gotcha. Gotcha. And is there a limit to like I guess how many of those you can kind of link together?
So you can link, I don't know the exact limit, but if you go to the aka.ms/penhaptics, you can learn more about that particular parameter on playback.
Okay, awesome, awesome. aka.ms slash penhaptics. Just a reminder for people, all the documentation and the code samples are there. Okay, so this is a good question because I think this is, we've talked a little bit about some of the scenarios where this would be useful, but I think that this is kind of a good broader question. When should I, as a developer, when should I be considering using haptic feedback or haptic interactions, I guess I should say?
I think this is a really important question. So you should be using haptic interactions when you're directly responding to pen input, such as inking or interacting with a control. Again, the example that you shared earlier about signing your name and then submitting, that's another example where your pen is giving direct feedback to the screen. So another example could be when you click on a button. Then you have click play. Or when you move the pen over an interactive object like a 3D model, you could play the hover waveform. Or like in our demo, you could change one of the default inking waveforms to be a little different in its intensity to match the kind of experience that you're looking for.
Okay. All right. That makes a lot of sense. Now, can I trigger haptics when I'm not receiving input?
No, and this is also a really important distinction. Haptics is closely connected to input, and it shouldn't be triggered when it doesn't relate to input, something that's going on where a user just took an action.
Okay, so I don't really need to worry about like getting feedback if I'm not putting something else out there, if I'm not giving input out there, and that kind of goes into the next couple of questions that we have. Are there user settings for the haptics?
Absolutely. In Windows 11, a user can configure if they want haptic signals for inking or interaction feedback, and they can adjust the overall intensity value. For example, a user could choose to only allow feedback for inking, in which case no interaction signals would be played.
Very cool. And how does the haptics intensity, how does that relate to your system settings for haptics intensity? So I guess how does the stuff in your app relate to the system settings?
Great question. System settings for intensity scale the app specified haptic intensity. So you can think of this like changing the volume level on your computer. Every application still plays their own volume, their own sound at a certain level. And so if you're an individual app, you can choose to be softer than that system volume, but you can't be louder than it.
Gotcha. So yeah, so the system is going to be kind of like your superset, but then the individual applications can still have their own settings within them. Okay, that makes sense. So where we talked about this before, but just to give people just get another pointer, where do we go to learn more about tactile experiences?
The number one place that you can go to learn more is our documentation online, which also includes our sample app that we showed off in our demos. This is available now at aka.ms/penhaptics.
All right, aka.ms/penhaptics. We've said that a couple times, but that is where the documentation is and where those code samples live. All right, so I think that this is going to be our final question. This is actually an interesting one. Does the haptic feedback, does it interfere with the user's inking experience? Like, when I'm trying to ink something, or if I'm like drawing my stick figures, I can't draw very well, but I do love to write a lot. If I'm doing that, is the haptic feedback, is that going to interfere with my flow? Is that going to mess up my beautiful stick art?
This is a super important question. And I think that this speaks to the nuance and the quality we get from these surface design products. The feedback is intended, it's designed, it's tested to be purely additive so that it doesn't interfere with the feeling of any inking. So as we mentioned, users also have the ability to change how strong that haptic feedback is if they desire it. So what you get is an extremely tuned and nuanced approach to providing feedback that really enhances the user's experience.
I like it. I'm glad to know that my stick figure art is safe. Michael, thank you so much for sharing this with us. This is so exciting. I cannot wait to see what developers create around these new tools and these new devices. I'm super excited. And aka.ms/penhaptics, right?
aka.ms/penhaptics, yep.
All right. Thank you, everybody, so much for joining us. We'll continue to answer questions in the chats, and you can always obviously ask us questions on Twitter and on other social networks if you have other questions. But Michael, thank you again for being here. This is really, really good stuff.
Thank you, Christina, and thanks everyone for tuning in.
All right. Thanks, everybody.